Namaste all of you. We'll straight away jump into the new chapter of 10th class NCERT, surface areas and volumes, in which we are going to deal about surface area of a combination of solids, surface area of combination of solids. Okay, before actually we enter into this particular chapter, it's very important that you should know certain basics of what kind of solids you are going to deal. You are going to deal here cuboid, cube, cylinder, cone, sphere and hemisphere. Understand? So these solids you are going to deal, and what is its curved surface area, lateral surface area, volume, all those things you should know. So that here we have written some charts. Okay, so from this you must have to know the formula relating to lateral surface area, curved surface area, lateral surface area for these two, cuboid and cube. Curved surface area rest because they have surface curved, therefore curved surface area. Understand? So lateral surface area, curved surface area, in which we are considering only the sidewise. Lateral surface area, because there is no curve in cube and cuboid, so we say that lateral surface area, leaving top and bottom. Leaving top and bottom, whatever is there, that becomes a lateral surface area. Understand? That in case of cylinder, cone, sphere and hemisphere, this lateral surface area is nothing but curved surface area, because that lateral surface is curved, therefore it is curved surface area. And total surface area and volume, all these formula is written, so you must know it. When it comes to cuboid or any solid is 3D, okay, three-dimensional figure. Any solid is three-dimensional figure. Okay, three-dimensional figure means how it is defined. It's defined in the form of its length, breadth and height. Length, breadth and height. Understand? So two-dimensional means only length and breadth. So we consider only length and breadth. So therefore it is called two-dimensional. Two-dimensional figures can be drawn on a plane. But three-dimensional figures require space, because height is considered. 3 dimensions, 3D, length, breadth and one more thing is height, length, breadth and height. So these are the 3 parameters so used to define the solid. Okay. Now in case of cuboid, this length, breadth and its height are all different, not the same. Length, breadth and height are different. And this cuboid consists of 6 faces. 6 rectangles. Cuboid consists of 6 rectangles, and opposite rectangles are equal. Opposite 6 faces it has. A cuboid has 6 faces whose opposite sides are equal. Understand? That means opposite sides are equal means if a top area, if you know, that is length into area means length into breadth, then the bottom area is also length into breadth itself, therefore it is 2 into length into breadth. Okay, then if you take the side way, opposite length into breadth, then length into breadth, that means to say that 2 since opposite sides are equal to each other, its total surface area we can say as L into H plus B into H plus L into H twice. Why? Because it's actually 2 L into H plus 2 B into H plus 2 L into B. It is length, breadth, because in one case we consider length comes, in one case it comes breadth. So by seeing this in this figure, this is length, breadth. If you are considering this area is nothing but length into breadth itself, or length into height, if you consider this particular area side, if you consider whose area is length into height. If you consider the down one, length, because this we have given as length into breadth, here is the area. Here length into height is the area. So don't see about just whether it is L or B. Since we have named that as L, B and H, so we are considering when we are calculating total surface area, we say that L into B or length into breadth. What is length into breadth? Is nothing but its area. If height is present in its area, then we say that breadth into height or length into breadth, in that way. Okay, so how many, why it is 2 into L into H plus B into H plus L into B? Why it is 2? Because opposite sides are equal, not 1, 2 is there. Okay, after taking common you will get this. This is total surface area, that means area of all the 6 sides. Lateral surface area is nothing but those sides which are there in the side lateral surface, leaving top and bottom. If you consider this room, the wall becomes lateral surface area, understand? Lateral surface, and top roof and bottom floor should not be considered. They will not become lateral surface area. All the walls becomes lateral surface. In that way, so how many surfaces are available, lateral surfaces available for cuboid and cube? 4. Understand? 4. Understand? Total surface area means 6. All the 6, top, bottom, and then rest 4 lateral surface area. All these things, area of all these sides, all the 6 sides. Lateral surface area, area of only 4 sides. Area of only 4 sides. Understand? Lateral, which is present laterally, sideway. Understand? Leaving top and bottom. How many sides are available in the cube and the cuboid? Lateral surface area 4. Total surface area 6. Understand this. A cube or cuboid is made up of 6 faces. How many faces? 6 faces. Understand? So in case of cuboid, opposite sides are equal to each other. Opposite sides are equal. But its length, breadth and height are different. Length, breadth and height are different. Okay. Lateral surface area of cuboid it is. Okay. 2 into H times L plus B. Lateral surface area. Its total surface area, lateral surface area means only 4 sides. Its total surface area is 2 times length into height plus breadth into height plus length into breadth. 2 times. Volume is nothing but length into breadth into height. Remember this, don't forget. Now it comes to, when it comes to cube, what is the difference between cube and cuboid? In the cuboid, length, breadth and its height are different, one thing, and opposite sides are equal. Only opposite sides are equal. Okay. In case of cuboid, cuboid is also made up of 6 faces. All these faces are square. All these faces are square. That means all these faces are equal to one another, not each other, one another. All these faces are equal. Because the cube is made up of 6 equal squares. 6 equal squares. Square means what? Its length and breadth are same. Since its length and breadth are same, its height also becomes same in case of cube. A cube is a 3-dimensional figure having all the 6 faces which are equal and square. Therefore, its height, its length, its breadth all are same. If you just find the value of its one side, then its length, breadth and height could be found easily. Why? Because it's all are same. If you have found one side, then its height also same, its breadth also same, its length also same. That is the difference here. Here length, breadth and height are different. In cube, in cuboid, length, breadth and height are different. In cube, length, breadth and height are same. Where in cuboid, same. Therefore, only one parameter is enough. One parameter if you know, that is one side of the cube if you know, then you can find everything, whether it's a lateral surface area or total surface area or its volume. Just one side is enough. Because if one side if you know, that's enough, so that all length, its length, breadth and its height, everything is same because equal. All made up of square. In that way, understand? Therefore, if you can see this is lateral surface area. What is area? Area is nothing but length into breadth. What is the length into breadth in case of square? Same. So length is A. If you take length is A, then breadth also A. So what is its area? A square. What is the area? A square. Why it's A square? If you consider one side of the square as A, then other side is also A. All the sides also are A. Right? What is its area? Area you know already. Length into breadth. So length into breadth means A square. Understand? So lateral surface area, I mean to say that one area of one side is a square. Lateral surface area, in case of lateral surface area, how many sides are present? 4 sides. Laterally 4 sides are present. All the 4 sides are equal, therefore 4a square. Lateral surface area is 4a square. Because 4 sides, here 4 refers to 4 sides laterally present. And area is a square, length into breadth. Length also a and breadth also a, therefore a into a square. So 4a square, remember, very, very easy. Total surface area. Total surface area means lateral surface area, 4 lateral surface area which are equal, and then top and bottom. Total how many faces are there? Total 6 faces, and all these faces are equal to each other. Therefore, area is nothing but area of one side is a square into 6a square. What is its volume? Length into breadth into height. Length is a, breadth is a, and height is a, therefore a cube. Did you understand? In this way, all these things, this is, see, very, very importantly, one thing I'll like to say here. If you want to find anything about the cuboid, okay, since the 3 parameters are different, length is different from height, height is different from breadth. Therefore, all the 3 parameters are required whenever you are dealing with the problems like cuboid. So always try to find its length, breadth, and its height. If you are dealing with the cube, so one side is enough. If one parameter is enough, one side if you come to know, whether it's a length or it's a breadth or it's height, one side if you come to know, then everything you can find because all are equal. Understand? This is very easy. And to find the curved surface area or total surface area or volume of cylinder, it is. Cylinder is the cylinder has a curved surface area, and top and bottom as its 2 base, which are nothing but circle of equal diameter, circle of same diameter. Understand? So here to find the curved surface area, total surface area or the volume, you must know its height h and radius, and breadth also becomes same itself. Its breadth also becomes radius itself. Therefore 2 parameters are required here to find the entire whatever the thing asked in the cylinder. Okay, what are those 2 parameters? Height and radius. If you know height and radius, you can easily find, so whatever the things given, problems or questions given based on this cylinder. Okay, now when it comes to cone, this cone is nothing but having the curved surface area with one circular base, and it's another, the next thing is it points, it tapers at one point. Okay, so this curved surface area evenly tapers at one point, having the base, circular base at the bottom, having the circular base at the bottom. Therefore you are going to get 3 things here. One is radius, circular base is there, therefore radius plus its height and slant height, slanting height or slant height, L. So 3 parameters are required when you are dealing with the cone. 3 parameters are required. Remember that it's a radius, its height and slanting height, L. How you find this L slanting height, slant height? How you find? So it is nothing but, so you can make a right angle triangle. Understand? So from a cone you can make a right angle triangle having known this radius and height. See here, having known this radius and height, you can easily find the slant height. Therefore, you should have the knowledge of Pythagoras theorem to find the slant height. Whenever you are finding slant height, always remember that. So this slant height, this slant side or height, whatever is there, that becomes the hypotenuse, and rest of the radius and height becomes other 2 sides having the 90 degree. Okay. Slant side is there, you know, that is the hypotenuse. Therefore, L is equals to, slant height is equal to square root of r square plus h square. If you apply that Pythagoras theorem, then very easily you can solve this. Understand? L you can find. 3 parameters are required. Now when it comes to sphere, so only one parameter is enough in sphere and hemisphere. Sphere is nothing but a ball. Understand? One parameter is enough to find whether it's curved surface area, total surface area, both are same here, because so all are even and with the same distance from the center. That is speciality of the sphere. So only if you know radius, then any sort of problem based on sphere and hemisphere easily you can solve. Okay, did you understand? Here in case of hemisphere, curved surface area plus one base is there. Curved surface area plus base. Curved surface area, when you consider curved surface area, it is 2 pi r square. Total surface area 2 pi r square plus one circle, area of one circle on top, that is base. Therefore 3 pi, what is the area of circle? Pi r square. So 2 pi r square plus 1 pi r square becomes 3 pi r square. And then volume is 2 by 3 pi r cube. Did you understand? So the thing is, all these things you must know. One thing is, if you know length, breadth and height, cuboid, easily you can find whether it's lateral surface area, total surface area or volume. If you know only one side, that means to say whether length or not, and whether length or breadth or its height, only one parameter if you know, then you can easily find all the questions based on this one. But in case of a cylinder, what you must know? You must know its two parameters you must know, that is its length and its radius. Sorry, its height and its radius. If you know height and radius, then you can deal with cylinder. And it comes to cone, three things: radius, height and slant height. And hemisphere and sphere, only radius. If you know radius, then everything is fine. Understand this one thing. Since we are dealing about the combination of solid, in this particular exercise 15.1, we are going to deal about the surface area, to find the surface area of combination of solid. What is this combination of solid? Two solids are joined. Two solids are joined. Understand? When two solids are joined, one point to be noted very importantly is, two solids are joined or combined, the area used to join these solids are lost. That means which is not available for the calculation of surface area. Why? Because it is used for joining. For example, if you join two cubes, how many faces are there in cubes? 6 faces. In one cube, 6 faces are there. That means 6 squares. If two cubes are joined, you are using one face of each cube, to join it. That means each cube loses one face for its surface area. That means you will have, after the combination, you will have 10 faces, not 12 faces. For example, if two cubes are combined, each cube has how many faces? 6. Total 12 faces. If they are combined, don't expect 12 faces. You expect only 10 faces. Why? Because two faces are used, or two squares are used to combine it. Therefore, it is lost. If you consider in that terms, here 6 face sides, here 6 sides, okay, area squares. If they are combined, one side is lost of each the cube. If it is lost, then available is 10 faces. On that basis also you can calculate, or on the basis of if they are joined, it becomes cuboid. Okay, so when it becomes cuboid, 6 faces are available. So on that basis also, based on this, what kind of joining you are making, based on that also you can calculate. Okay, so if hemisphere is joined, is combined on the cube or on the cuboid or whatever it is, the base area of the hemisphere which is used to combine, that is nothing but a circle, is lost. And the same area is lost by the cube or cuboid also. Did you understand? The place that is used for combination, or the area that is used for the combination, is lost in case of solids. That is not available for surface area. So we have to leave that and then rest calculation should be made. Understand? Now if you can consider cone. Cone, curved surface area plus yes, area of the circle on top, that is base area. Then if you consider hemisphere and these two are combined, joined, the circular area, the base area of hemisphere and the base area of cone both are lost. That is not available, okay, to calculate surface area. This is very important point to be noted. That's one thing. One more point is, if you are surmounting, that means combining. If you are surmounting hemisphere, understand, hemisphere on cone or cylinder, on cone or cylinder, you must note one point, that the radius of the cone and the radius of the hemisphere remains same, or radius of the hemisphere and radius of the cylinder remains same. This point to be noted. Understand? These 3 points, if you know very well, whatever things explained till now, then it becomes very easy. First thing is, note down all the formulae, how to calculate lateral surface area or curved surface area, total surface area and volume. So if you know this formula, then if you know what happens after the two solids are combined, surmounted, then very easily in various way we can solve the given question. Now the first question of exercise 15.1, what does it says? 2 cubes. How many cubes? 2 cubes. Remember the property of cube. Understand? Cube means 6 face. All the face are equal to one another. Only one parameter is enough. Only one parameter is enough to calculate everything that is required for the cube. Understand this properly. 2 cubes of each volume 64 centimeter cube, that is 64 cubic centimeter. Each cube whose volume is 64 cubic centimeter. That means 2 cubes are of same volume. Understand? Are joined end to end. Here it's seen. These are the 2 cubes which are joined end to end. When they are joined, they are going to lose one face. One side they are going to lose each cube. That I said, if both the cubes, total number of faces, if it is 12, after joining it becomes 10. Why? Because each cube loses one face. Understand properly. In that way also we can calculate. That is why explaining this. Are joined end to end. 2 cubes of each volume 64 cubic centimeter are joined end to end. Find the surface area of the resulting cuboid. When cubes are joined, it becomes cuboid. When they are joined, breadth becomes same, height becomes same, but only the length increases. So what will be the length of the cuboid, resulting cuboid, after joining the 2 cubes? That is double than the side. If it is 4 here, then the length will be 8, because 4 plus 4, each cube 4 plus 4, 8 it becomes. Understand every point properly. Many ways we can solve this. Okay, 2 cubes of volume 64 cubic centimeter volume. If volume is given, then it's enough. Only one parameter for the cube, so that we can find many things, height or length or breadth or whatever it is. What is volumes here? This is cube. The volume of the cube is by formula. If the side is A, then A cube. If the side is B, then B cube. If the side is C, and C cube. That's okay. Why it is A cube? Not to be confused. We have said that in a cube, A side is A, taken as A. If you take as X, then it becomes X cube, like that. Okay. So if a cube whose side is A centimeter, then its volume will be A cube. That is A cube. What is A cube? A cube is 64. What is this 64? Volume of a cube. What is given? Volume of each cube is given. Volume of cube number 1 is 64 cubic centimeter, cubic centimeter, and volume of cube number 2 is also, because 2 cubes of each volume is said, 64 cubic centimeter. Understand? This is what given. With this data, what we have to find, so it is made cuboid, okay, after joining it becomes automatically cuboid. So by cuboid formula also you can calculate, or by cube formula also you can calculate. That's I'll show you. So now volume is set, therefore A cube is equals to 64. Understand? A cube volume is equals to given 64. This can be written as A cube is equals to 4 cube. In terms of cube you can say 4 cube is nothing but 64. 4 times 16, 4 times 64. Okay. Now taking cube root on both the side, it becomes A is equals to 4. A is equals to 4. Each side became 4. A became for 4. What is 4? 4 centimeter. 4 centimeter. Now what is the beauty of this cube is, if A side is found, then its length, its breadth, its height, everything is 4 centimeter itself. In such case, if you think this as breadth, then this is 4. What is this? This is 4, and height equals 4. Understand properly. Now you are joining, what is this again? This is 64 cubic centimeter. Therefore the side breadth, length and height of cube number 2 also is 64 cubic centimeter. Therefore you will get side length, breadth and height 4 centimeters. Understand? Now you are going to join these cubes. When you are joining these cubes, what happens? The side which is used to join is lost. Therefore each cube are going to lose, one side. Understand? That means here 6 faces and here 6 faces. Total number of faces 12, and since they have lost one face each, so total number of faces 10. Remember this. Total number of faces after joining in a cube remains 10. Okay, 10 faces are there. Remember this, 10 faces. How you came to know? Now what is the area of the cube? Area is nothing but area of one side, that is nothing but square. A into A. Area is nothing but length into breadth. Length is A and breadth is A. Therefore area of one side of a cube is A square. That is A square. That is, A means what we have found here? 4. 4 into 4, 16 centimeter. What is this 16 centimeter? Area of one side. And all the sides are equal, where in case of cube all the faces are equal. All the faces are nothing but square itself. Now try to understand very seriously. After joining, how many faces we have got? We have got 10 faces. Each cube has a 6 face. That means 6 side. After joining, each cube loses one side each. Therefore 5 becomes 10. That means in this cuboid there are 10 squares of equal length. 10 squares of equal length joined. Understand? Now here we have found the area of one square is 16. So how many squares are there? 10 squares. Okay. That is area of 10 squares are available. Understand? In this cuboid is equals to 10 into A square. That means 10 into A square is nothing but 16. That is 160 square centimeter. This is the total area. What is asked? Find the area of the resulting cuboid. Find the area of the, so what is the area available? The area available was 10 squares, right? So what is the area of 1 square? Because all these 10 squares are of equal size. So all have equal areas. Therefore, area of 1 square multiplied by 10. Therefore, 160 centimeter square or square centimeter. What is the answer? Find the surface area of the result. Here surface area it said. Surface area is nothing but total surface area unless it is particularly asked lateral surface area. Here find the surface set. You should not find the lateral surface area. You should find total surface area. Understand? Find the resulting surface area of the cuboid. So without using the cuboid formula, you have got this very easily. But I don't want this. I will use the cuboid formula. If you say, okay, then no problem at all. We have got here, what is A value? A value here B is equal to breadth is equals to 4. Here you see that two cubes are joined. So here to here value is 4 and here to here the value is 4 and total length becomes 8. Understand this. And height there is no change in the height. Height is 8, breadth is 8. Only after joining length increases, that is 4 plus 4 becomes 8. With this data, so you can solve this problem in other way. How it has become cuboid. Cuboid of, after joining, cuboid of breadth 4 centimeter, height 4 centimeter, then length 4 plus 4, 8 centimeter. This is the one difference. Okay. Now take total surface area of the cuboid. Total surface area of the cuboid. If this is cuboid, you have to find total surface area of cuboid is equals to 2 into L into H plus B into H plus L into B. So you can write this simply as TSA. Now TSA is equals to 2 into what is L? L is nothing but 8. What is H? H is nothing but 4 into 4. Next plus B is nothing but breadth 4. Height is also 4 plus L is nothing but 8 and breadth is 4 and just a multiplication, that's all. 8 4 times 32 plus 16 plus 32. 32 plus 32 is 64. 64 plus 60, 16 is 80. 80 equals to 160 centimeter square. So if you use cuboid formula, then you will get 160 square centimeter itself. Value will not change at all. Or if you are doing directly, leaving the two faces which is joined, that means available 10 faces, you will get 160 square centimeter itself. Now, what is the surface area of the resulting cuboid after joining the two cubes? What is the area? This is nothing but, area is nothing but 160 square centimeter. Don't forget to write 160 centimeter square or square centimeter. Okay, because they have asked area. 160 square centimeter. Did you understand? Do you have any doubt? So it's all left to you. It's all depends on the way you think. So you can solve in any way. It's not like you have to use you have to go in one particular method itself. You can go in any other particular method if you know how to solve it systematically, okay, without changing the meaning of what is given. If you change the meaning of what is given, then everything is lost. Without changing that, so if you can solve this kind of questions, you can solve it in many ways, innumerable number of ways. You got the point? It's very easy. Either you can solve in this way, you get 160 square centimeter of area available, surface area. Okay, area is asked, therefore square. If cube is asked, then volume is asked, then it is cube. Okay, now, so if you use this formula and do, you will get 160 square centimeter itself. Did you understand? Now we'll jump into the second question of exercise 15.1. A vessel is in the form of a hollow hemisphere. Observe this, hollow hemisphere mounted by a hollow cylinder. Combination of hemisphere and cylinder, both are hollow. So after mounting, they become vessel. Okay, a vessel is in the form of a hollow hemisphere mounted by a hollow cylinder. The diameter of the hemisphere is 14 centimeters, and the total height of the vessel after combining hollow hemisphere with the hollow cylinder, the total height is now the height of the hemisphere plus the height of cylinder. Height of hemisphere plus the height of cylinder becomes the total height of the vessel. So total height of the vessel is 13 centimeters. Find the inner surface area of the vessels. Okay, of the vessel. Inner surface area of the vessel we have to find. Okay. Now see that. What are the things given? Diameter of the hemisphere is given. Diameter means the full, the length of this particular thing. What is that? 14. Diameter is 14. We know that diameter is nothing but 2 times radius. Diameter is given. Okay. Diameter of hemisphere. Diameter of the hemisphere is 14 centimeters. Okay. Diameter is nothing but what? D is nothing but 2r. Okay. This 2r, this diameter is nothing but 14. So 2r is equals to 14. R is equals to 14 by 2, which is nothing but 7. So we came to know the radius of the hemisphere is 7 centimeters. If diameter is 14 centimeters, diameter is nothing but 2 times the radius. Therefore, radius is nothing but diameter divided by 2. That is 14 divided by 2 is nothing but 7. So the full length is diameter 14. What is the radius? Radius is nothing but 7 centimeter. If radius is nothing but 7 centimeter, I told hemisphere or the sphere, okay, the distance of the curve from the center always remains same. That means everything is from this point, everything becomes radius. Here height also becomes radius. What is the height? Since the radius of the hemisphere is 7 centimeter, the height of the hemisphere is also 7 centimeter, because height is nothing but radius. Okay, so R is nothing but H is nothing but 7 centimeter. In case of hemisphere, radius itself is its height. Understand? So we have come to know what is this height. Height 7 centimeter. Radius also 7 centimeter. Okay. So now what is the total height of this vessel? Total height from here till here. Okay, from here to full total height. Total height is given. What is the total height? Total height is 13 centimeters. Total height of the vessel is 30. What is total height? Height of hemisphere plus height of cylinder. Total height is nothing but height of hemisphere plus height of cylinder, which is equals to 13 centimeter, which is nothing but 13 centimeter. What is the height of hemisphere? Here we have found height, radius, everything is same. So 7 plus. What is this? We don't know. We can find with this data available. Height of the cylinder. H is height of the cylinder is equals to 13. So transfer this 7 to 13 minus 7. 13 minus 7. What is 13 minus 7? 6 centimeters. What is its height now? So we have found height of the cylinder. Understand very carefully. Diameter was given. Diameter of the hemisphere. So by that diameter of the hemisphere, we have found a radius of the hemisphere, and radius of the hemisphere is nothing but height of the hemisphere also. So we have found. With that, total height is given. Total height is 13 centimeters. But total height of the vessel is nothing but height of the hemisphere plus height of the cylinder. Height of hemisphere is known 7 plus height of cylinder don't know, keep as it is equals to total height 13. So now by transferring 7 you will get 6 centimeters. Thus we have got 6 centimeters. Height of the cylinder is 6 centimeters. Total height is 13. Okay, 13 minus 7 is 6, which is nothing but height of, this is the height of cylinder. Okay, now you see that. So in the introduction I told you, if hemisphere is mounted on the cylinder, radius of cylinder as well as the hemisphere becomes same. Therefore radius of the hemisphere is 7 and therefore radius of the cylinder is also 7 centimeters. Okay, now you see that what we need to find is, find the inner surface area of the vessel. Inner surface area of the vessel. Inner surface area of the vessel. Both are hollow cylinders. Both, I mean to say, both solids are hollow. Both solids are hollow means, for example, if it is cylinder, a curved surface area plus 2 circles, 2 bases on top and bottom. Those bottoms are not there. Only available is the curved surface area. And hemisphere means curved surface area plus a circle base on top. Hollow means that is not there. Only curved surface area. That means total surface, inner surface area of the vessel. Total we have to find. Total inner surface area of the vessel is equals to curved surface area of hemisphere plus curved surface area of cylinder. Okay, it's a combination. Curved surface area of the hemisphere. Come here. Curved surface area of the hemisphere is nothing but what? 2 pi r square. 2 pi r square. Curved surface area. Okay. Total surface area is 3 pi r square because top circle is available here, not available. Curved surface area. Understand? Which is nothing but 2 pi r square plus curved surface area of the cylinder 2 pi r h plus 2 pi r h. In the introduction I told that for hemisphere or sphere only one data is enough to find lateral surface area, curved surface area, total surface area, volume or whatever it is. That is one parameter is nothing but r. Since r is available, so you can easily find what is this curved surface area of hemisphere. Now what are the things required for cylinder? For cylinder, 2 parameters are required, that is radius as well as height. But for the cone, 3 parameters, radius, height and slant height. Okay, here all these things are available. Okay, based on that we will solve this problem. 2 pi r square. 2. Pi is nothing but 22 by 7. R square, what is R? R is nothing but 7 centimeter. Understand? Then R square 7 into 7 plus 2 into pi, same, 22 by 7 into, what is R? R is nothing but 7. R is nothing but 7. What is H? Yes, cylinder. H is nothing but height of the cylinder. Don't take this H. This H here is about this one, hemisphere. So H, that means we are cylinder height. Cylinder height is 6 centimeters into 6. Okay. Now cancel this. What is available? 2 into 22 into 7 plus, cancel this, 2 into 22 into 6. 22 2 times 44 into 7 plus 44 into 6. 44 into 7 and 44 into 6. 44 7 times is 308 plus 44 6 times is 264. Okay. After addition, what you are going to get is 572 centimeters square is the area. 572 square centimeter or centimeter square is the area of inner surface of the vessel. Area of inner surface area of the vessels. Did you understand? Now we'll jump into the third question. A toy is in the form of a cone of radius 3.5 centimeters. A toy is in the form of a cone of radius 3.5 centimeters mounted on a hemisphere. Two solids are used, cone and hemisphere. Understand? Mounted on a hemisphere of same radius. Radius of, in case of cylinder, in case of cone, in case of sphere, hemisphere, radius factor is very important. Understand? So once the hemisphere, cone or hemisphere and cylinder is surmounted, then radius will be same. Understand? Since these two are joined, so radius of what the cone is the same as hemisphere, or hemisphere radius is same as that of the cone. That's what's given here. Okay. A toy is in the form of a cone of radius 3.5 centimeters mounted on a hemisphere of same radius. Same radius means 3.5 centimeters. Okay. The total height of the toy. Total height of the toy again came. Total height. Total height is nothing but height of hemisphere plus the height of cone. Total height of the toy is 15.5 centimeters. Find the total surface area of the toy. Total surface area of the toy is nothing but surface area of hemisphere plus surface area of the cone. Did you understand that? Now see that given things, let's write down. Radius. Radius. Radius of what? Radius of cone. We can write as RC is equals to what? 3.5 centimeters. Understand? Radius of the cone. And radius of hemisphere also same as that of the cone. Therefore, radius of hemisphere or hemisphere is equals to 3.5 centimeter. Radius of the hemisphere is 3. Since the radius of the hemisphere is 3.5 centimeter, its height is also radius itself. Therefore, its height also 3.5 centimeter. Understand here. Okay. Understand properly. Now, what is the total height? Total height. Total height. Total height of the toy. Total height of the toy is equals to 15.5 0.5 centimeters. Total height is given. What is this total height? This total height is nothing but height of hemisphere plus height of cone, which is equals to 15.5 centimeters. What is the height of hemisphere? Height of hemisphere, you know that height is nothing but radius of hemisphere. 3.5 plus height of cone, don't know, right, as it is equals to 15.5, which is total height. So keep height of cone as it is and transfer this height of hemisphere other side, 15.5. If in the total height, if height of the hemisphere is subtracted, then remaining height is nothing but the height of cone, which is nothing but 15.5 minus 3.5 is nothing but 12 centimeters. 12 centimeters. Understand? Total height here is there 15.5, in which height of the hemisphere 3.5, height of the cone 12 centimeters, total 15.5 centimeters. Okay, now you observe properly what are the parameters required to find any area or volume of hemisphere. Only radius. So we have no problem with the hemisphere at all. R we have got. R is enough. Only one radius is enough so that we can find its surface areas or we can find the volume. That one unknown thing, if we know, then we have no problem with the hemisphere at all. But for the cone, so we need three parameters. What is that? Its radius, or it is there, no problem at all, or 3.5, it is there. Its height we have found, height 12 centimeters. But one more thing very much required is L. L is nothing but slant height. Without slant height, we cannot proceed with the cone at all. Understand? We can very easily proceed with hemisphere. This tau is nothing but the combination of hemisphere and cone. Understand? So separately we have to find its area and we have to add it. That's the thing. To find hemisphere of its area or of its volume, only one unknown thing is required, that is radius. It is there and we have no problem with hemisphere. But to find the cone aspects of its area or of its volume, three unknown things we should know, that is its radius, height and slant height. Radius height is there when we do not know its slant height. Okay, so first we need to find the slant height of the cone. Once we find the slant height of the cone, then we can proceed with this question very easily. I have no problem with the hemisphere. I have problem with this cone where slant height is required, because the total height is find the total surface area. Surface area is nothing but surface area of cone plus surface area of hemisphere. What is the surface area? Lateral surface area of cone, pi r L. Pi r L. Or pi r, if it is total surface area we cannot consider. Why? Because the base area which is joined with the base area of the hemisphere is lost. Only available is curved surface area. Therefore, curved surface pi r L. H is also not required. L is required. Okay, r L is required. How you find r L? This is nothing but you can see that if you consider this as a right angle triangle, slant height, which is nothing but L. How you find L? This is right angle triangle. If you think it is A, B, C, ABC is the right angle triangle, where AC square is nothing but what? L square is equals to H square plus R square. Because this particular thing forms height and radius and slant height forms right angle triangle here. Therefore, to find the slant height, remember this, L square is equals to h square plus r square. Therefore, you must know h here. R you already know h. Thus we have found h. Understand this. L square is equals to h square is nothing but h is nothing but 12 here. Height of the cylinder. Understand? Slant height of the cylinder we are finding. 12 square plus the radius is 3.5 whole square. L square is equals to 12 square is nothing but 144 plus 3.5. 3.5 into 3.5, 12.25 it comes. So we will make in other way 7 by 2 whole square. 3.5 is nothing but 7 by 2 whole square, because 7 by 2 is nothing but 3.5 itself. Okay, for the sake of easy calculation, is equals to 144 plus this is 49 by 4. 49 by 4. Understand? Now take LCM 4. To add this 144 with 49 by 4, you should take LCM. LCM is 4. That means whole multiply and divide by LCM. That means L square is equals to 144 into 4 plus 49 whole divided by 4. Multiply this. 4 times 16, 1 remainder. 4 times 16 plus 1 remainder, that is 7. 4 ones 4 plus 1, 5, 76 plus 49 by 4. Now L square is equals to 576 plus 49, 625 by 4. 625 by 4. Understand? 625 by 4 can be written as 625 the square number. Write down 25 square by 2 square. And now take square root on both sides. After taking square root on both sides, it is L is equals to 25, square and square root gets cancelled, 25 by 2, which is nothing but 12.5. 12.5 centimeters. L is equals to 12.5 centimeters. Slant height of the cone we have found. Understand? So once we find this, now we can proceed with the question what is asked. Understand properly. Why I am telling you this is to find the volume or area or whatever it is, what all the parameters are required, you must know. For hemisphere, R is required, which is there. For cone, L is required, H is there, and R, H and L is required. Okay, R, H is there, L is not there. How we found L? We have found in this way. We have to understand. Now what is asked? Find the total surface area of the toy. Total surface area of the toy is equals to curved surface area of hemisphere plus curved surface area of cone. Curved surface area of hemisphere plus curved surface area of cone. Okay, now total surface area of the toy is equals to curved surface area. Curved surface area of the hemisphere is 2 pi r square. 2 pi r square. Only r is unknown here, which also we know now. Plus curved surface, here you can see that curved surface area of hemisphere, curved surface area of the cone makes the complete total area of this toy. Okay, this is cone. Curved surface area is pi r l. Pi r l. So total surface area of the toy is 2 into pi value 22/7 r square. R square is nothing but what? R is nothing but 3.5. R square is nothing but 3.5 whole square. 3.5 whole square. Understand? Plus pi is nothing but 22/7. R 3.5. L we have found here 12.5. Understand? Now is equal to 2 into 22 is 44/7. 3.5 can be written as how? 7/2 whole square plus 22/7. 3.5 can be written as 7/2 into 12.5. Okay, 44/7 into, this is nothing but 7 into 7, 2 into 2 plus 2, 7 gets cancelled up, 2 11s, 11 times 22, 11 into 12.5, 11 into 12.5, 7 gets cancelled up is equals to, this is, understand properly, 22 times, okay, 22 into 7/2 plus 11 into 12.5, that is 137.5. Here 2 11 times, 11 into 7 plus 137.5. 11 to 7 is nothing but 77 plus 137.5. This is nothing but 77.5 4 centimeter square. Total surface area of the toy is 214.5 square centimeter or centimeter square. What you are asked to find? The total surface area of the toy. What is the total surface area of the toy? 214.5 centimeter square. How? In a very simple way, easy way, we have found this. What is asked? Which are the combination of two solids here in the toy? Hemisphere and cone. Okay. So what is asked? Curved surface area, which is nothing but curved surface area of hemisphere, curved surface area of the cone. Okay. To find the curved surface of area of the hemisphere, what is required? R is required, which is there. So we did not touch it. What was required to find the curved surface area of the cone? So, cone means three parameters are required: R, H and L. R, H was there. Somehow we found, but L we found by using Pythagoras theorem in this formula. So we got this. And just what that total surface area is nothing but curved surface area plus of hemisphere plus curved surface area of cone. Then just did this. Ultimately we got 214.5 centimeter square. Understand? Now we'll jump into fourth question. A cubical block of side 7 centimeters is surmounted by a hemisphere. A cubical block of side 7 centimeters is surmounted by a hemisphere. What is the greatest diameter? Greatest diameter the hemisphere can have if a hemisphere is surmounted on a cubical block. Okay. What is the greatest diameter that the hemisphere can have? First question. Find the surface area of the solid. After surmounting hemisphere on the cubical block, what is the surface area, total surface area. Okay, and also we have to find the greatest diameter the hemisphere can have. Okay, understand question properly. What is the greatest diameter that hemisphere can have if you are surmounting hemisphere on the cubical block? Cubical block is nothing but cube. Cubical block is nothing but solid cube. If you are surmounting, maximum what is the length? Cube means you should know height, its length, its breadth, all are same because 6 squares constitute this cube. Squares of equal side. Okay. Now it is given cubical block of side 7 centimeters. That means 7 centimeters height, 7 centimeters length, 7 centimeters breadth, everything. If you are surmounting hemisphere on this cubical block, maximum how much you can extend? How much is the length of the side? What is the length of the side? 7. So diameter, maximum diameter of this hemisphere that can have is 7 centimeter itself, not more than that. More than that, block is not there. The block length itself is 7 centimeter. If block length itself is 7 centimeter, how can you have more than that? Diameter can never be more than that. So diameter, the maximum diameter that hemisphere can have, if you surmount this particular hemisphere on a cube of side 7 centimeter and cubical block of side 7 centimeter will be 7 centimeters itself. So first question, what is the greatest diameter the hemisphere can have? Minimum means 7, 6, maximum 7, 6, 5, 4, 3, 2 you can have. Okay, but maximum is 7. First question, what is the greatest diameter the hemisphere can have? 7 centimeters is the greatest diameter hemisphere can have. Hemisphere can have. Okay, with that itself we will proceed. If the diameter of the hemisphere DHS, diameter of the hemisphere, greatest diameter of the hemisphere is 7 centimeters, then what is its radius? Based on that we will calculate. Diameter is nothing but 2r, which is nothing but 7. R is nothing but 7 by 2, or 3.5 centimeters. We have got some information about hemisphere. What is that? Radius we have got based on this. What is radius? 3.5 centimeters. That is enough to find volume or area or whatever of the hemisphere. Okay, so to find the hemisphere, what is required? We have got that. Okay, now we'll see the cubical block. Cubical block. Okay, so this cubical block whose side is 7. Side is 7. If side is 7, then what will be the area of one side, one square? 7 into 7. 7 into 7. Understand? This is about hemisphere. Area of one side of cubical block. Total how many sides are there? 6 sides. Okay, one side. Okay, one side is nothing but area. Here is length into breadth. What is length? 7. What is breadth? 7. 77. Understand? So 49 centimeters square. 49 centimeters square is the area of one side of the cubical block. Such how many sides are there to make one cube? How many sides? 6 sides. Therefore, total surface area of cubical block cubical block is equals to 6 a square. You can see that 6 a square. Here a square is nothing but what? 6 a square, which is nothing but a square is nothing but what here? This is nothing but a square. A square is nothing but 49. Therefore 6 into 49. 6 into 49. Okay. What is this 6 into 49? 9. 6 times 54. 4. 6 times 24. 4 6 times 24. 24 plus 5. 24 plus 5. 29. 294 centimeters square. Remember, what is this 294 centimeters square? Is nothing but total surface area of the cubical block. Understand? We have found that based on the information given, that is one side is 7 centimeter. Understand? Area of one side is 7 into 7, that is a square. A into a square, 7 into 7, 7 into 7 square, that is nothing but 49. So total surface area is nothing but 6 into 49. Area of one square, such 6 squares are there. 294 we have got. But that is not the question. The question is, find the surface area of the solid which is nothing but cubical block, as well as on that what is there? Hemisphere. Now you can easily say that, sir, total surface area of the solid is nothing but surface area of cubical block which we have found, and surface area of this hemisphere, add that, so that we will get, no, not like that. Understand? It is not possible to add in that way. How you can add? When two solids are surmounted, I said in the introduction, the area which is used to surmount or join or combine is lost. Here, base area of the hemisphere. What is the base area? Base area of the hemisphere is nothing but a circle. Okay, that is pi r square. This pi r square, base area of this hemisphere, base area which is nothing but pi r square. Area of the circle is nothing but pi r square. Pi r square of this hemisphere is mounted on the cubical block. Okay, the cubical block now loses pi r square area of 294 centimeters square area, total area, surface area of this cubical block. How much it is lost? Pi r square area is lost. Why? Because pi r square area is used to surmount hemisphere on cubical block. Therefore, it is lost. That is why when we calculate surface area of this particular solid, understand, surface area of this solid is equals to okay, area, surface area of cubical block which is nothing but this one, plus curved surface area of hemisphere minus base area is nothing but pi r square of the hemisphere, that is pi r square. Why pi r square? Hemisphere base is a circle whose area is pi r square, which is used to surmount on the cubical block. Therefore, cubical block loses that area. Understand? Available area is 6 a square plus area, curved surface area of the block minus what is, how much area is used, pi r square area is used. Therefore, it is minus. Understand this point to be noted. Okay. Now, surface area of cubical block. Surface area of the cubical block. Total surface area 6a square. Is it not? 6a square plus curved surface area. Curved surface area of hemisphere 2 pi r square minus pi r square. Okay. Understand. This is nothing but 6a square is nothing but what? 294 plus 2 pi r square. 2 pi r square. 2 into pi is 22 by 7. 22 by 7 into r square is 3 point, how much? 3.5 into 3.5 minus, see, so this is the elaborate method I am doing. So you can directly cancel here 2 pi r square minus pi r square. 2 pi r square minus 1 pi r square is nothing but 1 pi r square. Directly you can do here itself than doing all those. Did you understand? See here. This is nothing but 6 a square is nothing but 294 plus, understand, what is this? 2 pi r square. In the 2 pi r square, if you minus pi r square, pi r square same is there, see, huh? 2 pi r square minus 1 pi r square is nothing but 1 pi r square. 1 pi r square. Okay. Now see here. 294 plus pi is nothing but 22 by 7. 22 by 7. R square 3.5 into 3.5. 3.5 into 3.5, which can also be written as 294 plus 22 by 7. 3.5 can be written as 7 by 2 into 7 by 2. 7 gets cancelled up. What is remaining? Right on here, which is nothing but what? Total surface area of the solid, okay, is equals to 294 plus 7 got cancelled up, 22 by 2 into 7 by 2. 211 times 294 plus 11 7 times 77 by 2. 77 by 2. Okay. This 294, 77 by 2 is 38.5. Okay. Now, (294) plus 38.5 you have got. After adding that, you will get 332.5 centimeter square or square centimeter is the total area of this solid, total surface area of this solid. Understand? In a very easy way we have found. It's very easy, very simple way. All that we should know is what are the two kinds of solid that is combined. That is one cubical block plus one hemisphere. Cubical block area very easily you can find surface area. Okay, because 6 surfaces are there which are equal. So 6a square, 6 here a is nothing but 7 times 49. So 49 into 7 you will get 294 that you have got. and curved surface area of hemisphere is nothing but 2 pi r square. Since this hemisphere you are going to mount on the block, the base area, that is pi r square, is used up to mount, therefore block loses pi r square. That is why here it is 6a square plus 2 pi r square, curved surface, total surface area of the cubical block plus curved surface area of the hemisphere, but minus pi r square. This minus is nothing but this block loses this area which is used up in mounting. This is very important. Understand? So you can find directly by applying whatever the value, substituting whatever value, or directly by subtracting 2 pi r square minus pi r square, you will get this. Understand? 332.5 centimeter. Okay, we'll jump into next question. A hemispherical depression is cut off from one face of a cubical wooden block, one face of a cubical wooden block, such that the diameter L, understand here, the diameter L of the hemisphere, the diameter L of the hemisphere is equal to the edge of the cube, is equal to the edge of the cube. What we need to do is determine the surface area of the remaining solid. Determine the surface area of the remaining solid. This question is just like the previous one, the fourth question, where hemisphere is surmounted on the cubical block. Here hemisphere depression is made, that means hemisphere is carved out of this cubical block, where in the previous question it was surmounted, attached. Hemisphere is attached on the cubical block, but in this question it is removed. The hemisphere area is removed, one and the same here. When it comes to surface area, one and the same here. When it is attached, hemisphere is attached on the cubical block, or it is removed, cube is going to lose pi r square area. That point to be noted. Whether it is attached, whether hemisphere is attached on the cubical block or hemisphere is removed, depressed out. What the cubical solid block will lose is the pi r square area. This to be noted very carefully. Okay. So if you know that, then very easily we can proceed. What is that? Diameter of the hemisphere is L. If diameter, what is given? Diameter. Understand? Diameter of hemisphere is L. If diameter is L, diameter is nothing but 2r, which is nothing but L, then r is equals to L by 2. Radius we have got, from diameter we have got radius. Radius is L by 2. This one particular thing is enough to find whatever of this hemisphere. This one unknown factor, radius, if we have, then curved surface area, total surface area and volume, everything can be found. Only thing what we need to know is L, this r, radius. Radius, one thing is required. But if it is cubical block also, only if the side of the cubical block is known. You know that cubical block is made up of 6 equal squares. So if a side is known, that's enough. One area we can find A into A. If one side is A, then A into A is the area of one side. If one side is, here it is said, the diameter L of the hemisphere is equal to the edge of the cube. Is equal to the edge of the cube means what? Means that a side of this cubical block, the length of that side is L. If it is L, then enough. Edge is L means its length is L, its breadth is L and its height is L. That's enough. That particular one information is enough to find LSA, lateral surface area, total surface area and volume of this cubical block. Understand? Now, you know that L is the edge of the cubical block. So that what is the area of one side? Area of one side of cubical block is area of one side of cubical block is what? L is the length of one side. Therefore, L square. Such how many sides are there? 6 sides, equal sides are. Therefore, total surface area of cubical block is 6L square. We have got this. Understand? So we got 6L square, and then R value we know, so that we will get the curved surface area of hemisphere also. Then very easily we can now enter into what is asked. What is asked? Determine the surface area of the remaining solid. What is the surface area available in this solid? E is nothing but surface area of solid. After carving that, what is available? Total surface area of cube plus curved surface area of hemisphere, which is there inside, minus what the cube lost, pi r square area it has lost. Therefore, minus pi r square area, because the base area of the hemisphere is nothing but a circle, and the area of the circle is nothing but pi r square. Understand? Now, total surface area of the solid is equals to total surface area of the cube. What is the total surface area of the cube? 6a square. 6a square plus curved surface area of hemisphere is 2 pi r square minus pi r square here. 6. What is a? A is nothing but L. So a square is nothing but L square plus 2 pi r square minus 1 pi r square is nothing but 1 pi r square is equals to 6L square plus pi. What is r square? R is nothing but L by 2. R square is nothing but L by 2 whole square. 6L square plus pi L square by 4. Remove the common factor outside, so that L square is the common factor. 6 plus pi by 4 is available. Okay. L square. Now you take LCM. You add this 6 plus pi by 4, it is not possible. Add whole and fraction, you have to take LCM. LCM is 4. So divide and multiply with the LCM for individual term. Thus it becomes 6 into 4 plus pi by 4 into 4 and whole divided by 4. That is L square. 6 into 4 is 24 plus pi whole divided by 4. This can be written as L square by 4 into 24 plus pi, or pi plus 24. All these are nothing but what? Equals to area of the given solid. Determine the surface area of the remaining solid. What is the surface area of the remaining solid? It is L square by 4 times 24 plus pi, 24 plus r, pi plus 24. Did you understand? Very simple, very easy way we have solved. So if you have any doubt, no need to worry, keep on watching the video several times, you will come to know. Now we will jump into the 6th question. A medicine capsule is in the shape of a cylinder with two hemispheres stuck to each of its ends. The length of entire capsule is 14 millimeters. The length of entire capsule is 14 millimeters and the diameter of the capsule is 5 millimeter. Diameter is 5 millimeters. Find the surface area. Find the surface area of this capsule. Capsule, it is a medicine capsule, not the tablet, round tablet. It is a capsule. Okay. This is actually in which form it is said? It is in the form of a cylinder where to its ends two hemispheres attached. That means it is a combination of this capsule is a combination of three solids. Okay. So that is cylinder and two hemispheres. Cylinder and two hemispheres. These two hemispheres are equal. Why? I'll tell you. See here, its diameter is 5 millimeter. So I said you long back, if hemisphere is surmounted on cylinder or cone, the radius remains same. If radius of cylinder and hemisphere remains same, I said. If radius remains same means its diameter is also same. That means the cylinder diameter is also 5 millimeter. The hemisphere's diameter also 5 millimeter. Okay. So this confirms that diameter, if same, then radius are same. If radius are same, then these two hemispheres which are attached at each end of the cylinder is same. Understand? So on that basis, now we'll see. What is given? Diameter. Diameter of the capsule is 5 millimeters. 5 millimeters. Okay. If diameter is 5 millimeter, D is equals to 5 millimeter. Then what is its radius? Diameter is nothing but 2r. 5. R is nothing but 5 by 2. We have got radius. Radius is 5 by 2 millimeter or 2.5 millimeter. Understand? Now, radius of hemispheres and cylinder we came to know. Okay, since all are attached, all are combined in the capsule, so radius remains the same for two hemispheres as well as two cylinder. Okay, so to this cylinder the radius remains same. What is the radius? 5 by 2 millimeter. Then what is the next information given? The length of the entire capsule is 14 millimeters. Length of entire capsule is 14 millimeters. Okay, length, that is total length. Total length is equals to 14 millimeter. What is this total length? Length of capsule plus length of cylinder plus length of hemisphere. Sorry, length of hemisphere, two hemispheres, and length of this cylinder. Understand? So total length is equals to length of two, as you can see, two hemispheres plus length of cylinder. Okay, so that is the total length. What is that? That is equals to 14 millimeter. Now you have to understand one thing properly. This entire length is nothing but height of the cylinder. Entire length is nothing but the height of the cylinder. Understand? And the length of this hemispheres is nothing but its radius. Nothing but its radius. Height of the hemisphere is nothing but its radius, and radius we have here. Okay. So thus length of two hemispheres is nothing but 2 into 5 by 2. 2 into 5 by 2 plus length of cylinder or height of the cylinder, which we don't know, is equals to 14 millimeters. Complete. Understand? So the thing to be understood here is the length of entire capsule is 14 millimeter. That keep in mind. Next is, what is this length of entire capsule? Is nothing but length of two hemispheres plus one cylinder. Two hemispheres plus one. Length of two hemispheres means what? It's nothing but its radius. Radius of one hemisphere is equals to length of the hemisphere itself. Understand this. Length, radius both same here. Length or radius is equals to 5 by 2, one hemisphere. How many hemispheres you have got here? Two hemispheres. Therefore 2 into 5 by 2 plus length of the cylinder is nothing but height of the cylinder, that is h. We do not know. We have to find that. But this data is enough to find this. Is equals to what? Complete length 14. Understand? Now 2 gets cancel up. 5 plus h 14. H is nothing but height of cylinder. 14 minus 5. H is equals to 9 millimeter. So with this, what we came to know is the length or the height of the cylinder we came to know. Understand what all we came to know? I'll write here. Okay, radius. So how many, what are the solids combined here? 2 hemispheres and 1 cylinder. Okay, hemispheres first. I'll say hemisphere. Hemisphere. What you must know to find its curved surface area, total surface area or volume, what one particular thing you should know, that is nothing but radius. Rest all the value is known value. 2 is 2 itself, pi is nothing but 22 by 7, but only unknown value is r. If you know r, that is enough, that is sufficient to determine curved surface area, total surface area and volume. Understand? So one parameter that is required is radius, and that radius of hemisphere is 5 by 2, which we have. So easily we can enter into this problem. Okay. Now, so this is a combination of solid and cylinder is also there. What are the parameters required for cylinder to deal with its curved surface area or total surface area or volume? What are the parameters for in case of cylinder? H, height, and r. Height and r. R is nothing but radius. Radius is there. What is radius? 5 by 2. Radius of hemisphere is same as that of radius of cylinder. What is the height? Just now we have found. That is 9. Height is nothing but what? Its length. So these two parameters, you can see that cylinder RH, RH, RH. Other than that is not required. Okay. RH is enough, which we have got. So all these things we have done to find this. Okay. These are the clues given so that we can find its radius and its height. Okay. So once we find this particular thing, then whatever is the problem, easily we can solve it. So what is asked to find? Find the surface area, that means total surface area of 2 hemispheres and 1 cylinder. Why I said 2 hemispheres and 1 cylinder? Because the total capsule area is nothing but 2 hemispheres plus 1 cylinder. Understand? So that is total surface area of capsule is equals to what? Curved surface area. How many curved surface area? 2 curved surface area of hemisphere plus this completely. The complete capsule is nothing but curved surface area of this complete, or surface area of this complete capsule is nothing but 2 curved surface. What is present in this capsule? See properly. In this capsule, curved surface area of cylinder is present, and curved surface area of what? Hemisphere is present. See, curved surface area hemispheres, 2 hemispheres and 1 cylinder is present. Okay. So if you find that, then we have found the curved surface area, surface area of entire capsule. Understand? Total surface area of capsule is nothing but what? 2 curved surface area of hemisphere plus curved surface area of cylinder. Understand? Understand properly. Now, 2 curved surface area of hemisphere. Okay, to maintain. What is the curved surface area of hemisphere? 2 pi r square plus. What is the curved surface area of the cylinder? 2 pi r h. 2 pi r h. Okay. This is nothing but what? Total surface area of the capsule. 2 into 2, 4. Pi. Pi is nothing but 22 by 7. This is 2 into 2 is 4, or you can keep as it is. That's no issue. 22 by 7. What is r square? R square is nothing but 5 by 2 into 5 by 2. R is nothing but 5 by 2. Therefore, r square is nothing but 5 by 2 into 5 by 2. So, 2 times 4. So, here 4 get cancel up. Next plus 2 into, what is pi? Pi, always remember, 22 by 7. Or you can take it as 3.14, etc. But here 22 by 7 will take. What is r? 5 by 2. What is h? H is nothing but 9. Okay, now see here. 22 into 25 by 7. 22 into 25 by 7 plus 2 gets cancelled up. Okay, 22 into 5 9 times 45 by 7. Understand? 22 into 25 by 7. 22 into 45 by 7. Okay. 22 into 25 is 550 by 7 plus 22 into 45. 22 into 45 is 990 by 7. Okay. 22 into 25 is 550 by 2 times 25, 2 times 50 into 50 plus 5, 550 by 7. 20 into 45 is 990. You can calculate that. 550 by 7 plus 990 by 7. Denominator is same. Since the denominator is same, you can write as 550 plus 990. 550 plus 990 by 7. 550 plus 990 by 7. Okay. 550 by 990 is nothing but 4. 1540 by 7. Understand? Now 7 2 times 14, 2 times 220. What the answer we have got? 220 millimeters square. 220 millimeters square. Okay. What is the surface area of this capsule? The surface area of the capsule is 220 square millimeter or millimeter square. Understand? How we found this capsule is nothing but the combination of 3 solids. Which are those 3 solids? 2 hemispheres and 1 cylinder. These 2 hemispheres are equal. Okay, therefore here we have considered 2 into curved surface area of hemisphere we have considered, because radius is same. What is the radius? 5 by 2. So if radius is same, then radius is same for cylinder also. So cylinder radius is also 5 by 2. And h, how we found? By taking this length, entire length. Okay, entire length is nothing but what? Length of hemispheres plus length of cylinder. Length of hemispheres is nothing but what? It is nothing but the radius. Okay, on that basis, so we have derived r value and h value, that is sufficient. R and h value are sufficient to find the curved surface area. Understand? If at all we are dealing with the cone, then we need L value also. Understand? Since we are dealing with cylinder and hemisphere, for cylinder R is sufficient. Okay, for hemisphere R is sufficient, and for cylinder R and H is sufficient, which we have got here. And based on what is asked, then surface area it is asked. Surface area of capsule is nothing but what is the capsule? Capsule is nothing but 2 hemispheres plus 1 cylinder. So surface area of 2 hemispheres plus surface area of 1 cylinder. Then as usual, write down the formula and substitute. You will get the value 220 millimeter square is nothing but the surface area of this capsule. Understand? Now we'll see the next 7th question. A tent is in the shape of a cylinder surmounted by a conical top. If the height and diameter of the cylindrical part, are 2.1 meter and 4 meters respectively, and slant height of the top is 2.8 meters. Slant height of the top is 2.8 meters. Find the area of the canvas used for making the tent. Area of the canvas used for making the tent. First question. Also find the cost of the canvas of the tent at the rate of rupees 500 per meter square. 1 meter square of this canvas cloth rate is 500 rupees. 1 meter square. Understand? Now, so what are things given? It is nothing but a tent. Okay, the tent is made up of two kinds of figures. One is cylinder, and on top of that a cone. That is combination of cylinder and cone. Since it is the combination of cylinder and cone, here radius remains the same, because on top of the cylinder cone is fixed in that way. Okay, cylindrical bottom, top is the cone which is fixed, so will have the same radius. One thing to be noted. Okay, now what are the things given? If the height of the diameter, if the height and the diameter of the cylindrical part are 2.1 meters and 4 meters respectively. Understand? Cylindrical part height and diameter is given. Now one by one, what are the things given? We'll write down. Okay, cylindrical part. What is given? Height. Height of cylinder. How much? 2.1 meters. Then diameter. Diameter. That is DC. It is nothing but 2R. Both one and the same itself. Is equals to 4 meters. If diameter is 4 meters, then radius is nothing but 4 by 2 meters. Okay, so we have got two things from this question. What is that? Height of the cylinder is known, 2.1 meter, and the diameter is given. From that we have derived radius. So height and radius are there for the cylindrical part. So to find the curved surface area, what is required? Radius and height, which is there. So cylindrical curved surface area we can easily find, no issue at all with this data given. Understand? And then what is given? Slant height of the top is 28. What is on the top? Top is nothing but cone, conical part it is. Slant height is given. Okay, conical part is conical part. Things given is slant height. Slant height is nothing but L, which is nothing but 2.8 meters. 2.8 meters. Understand? And the radius both same, I said. Both of cylinder and cone are same here because they are mounted one on the other. Therefore, here radius is equals to 2 meters. Now we will come to the formula and see that cone, to find the curved surface area or total surface area, what are the two parameters required? R and L. H is not required. Though in the cone, R, L and H are the things which is required to find the volume or whatever it is. But here in this particular case, so we no need to find the height at all. Why we no need to find the height at all? Because in this part, slant height and radius is enough to find curved surface area or total surface area. As you can see in the formula, there is no height factor at all. Height factor comes only in volume. Got the point? Therefore, all the required data is there to find the solution of this particular question. Okay. So first thing is we have to find the area of the canvas used for making the tent. Canvas is nothing but a kind of a rough, strong cloth used for making tents, and even it is used for painting also. Understand? Now two things are there. So what is, find the next question is find the cost of the canvas. First we will find the how many meters, square meters of this canvas is used to make this tent, and then based on that how many meters we get, we will find the cost of that. Okay, using this data. What we have to find the area of the canvas. Find the area of the canvas. Area of the canvas is nothing but area. So one more thing to be noted. Note that the base of the tent will not be covered with the canvas. This base cylindrical base is nothing but circle where it is not used, canvas is not used. That means that you have to find only curved surface area of the cylinder and curved surface area of cone. Okay, so total area required, total area is equals to curved surface area of cone plus curved surface area of cylinder. What is curved surface area of the cone? Pi r L plus curved surface area of the cylinder 2 pi RH. All these data are available. Pi as usual 22/7. R we have found here, R is nothing but 2. Slant 8 is given 2.8 plus 2 here. Pi is nothing but 22/7. R is 2. H is 2.1. Okay, now 22 into 2 is 44. As you can see that if you just neglect this decimal, this is nothing but as though 28 can be divided by 7, but 2.8 also can be divided by 7. That gives the result 4 times 28, therefore 0.4. When 2.8 is divided by 7, you will get 0.4 plus this is 44, 2 into 22. You can see that 7 and here 2.1 as of 21. 21 could be divided by 7. So what is that? 21/7 is nothing but 3, or 7 3 times is 21. So we can say that 0.3 when 2.1 is divided by 7 is 0.3. Okay, 2 into 0.3, this one. Now the next step is 44 into 0.4 is 17.6 plus 88. 44 into 2 is 88 into 0.3. Again 17.6 plus 88 into 0.3 is 26.4, which is nothing but 17.6 plus 26.4 44. Okay, 44.0, that is 44 meter square. What is the area of the canvas required to make this tent? 44 meter square area of the canvas is required to make this tent. Understand? So we came to know that 44 meter square of this canvas is required to make this tent. But this is the first question. First question is find the area of the canvas used for making the tent. What is the area of the canvas used? 44 meter square. 44 meter square. Now this is finished. Second question is find the cost of the canvas of the tent at the rate of rupees 500 per meter square. 500 per meter square, that is for 1 meter square it cost 500 rupees. Understand? How many meter squares are there? 44 meter squares are there, this canvas. Okay, so that is cost 500 rupees per meter square. Okay, now so how much is there? 44 meter square, therefore 500 into 44. 500 into 44. 500 into 44 is nothing but what? 22,000 rupees. 22. Okay, understand here? So what is the required amount? to make this canvas? What is the cost of this canvas to make this tent at the rate of 500 rupees per meter square? That is nothing but rupees 22,000. 22,000 rupees is required if 1 meter square canvas is 500 rupees. You understand that? Now we'll jump into the next question. Question number 8. From a solid cylinder whose height is 2.4 centimeters and diameter 1.4 centimeter, a conical cavity of same height and same diameter is hollowed out, scooped out. Find the total surface area of the remaining solid to the nearest centimeter square. To the nearest centimeter square. Now understand here, from a solid cylinder, it is not the hollow cylinder, it is solid cylinder. Solid cylinder means having curved surface area and two bases, one on top and one on bottom, which are nothing but circle. All these things are there. Two bases which are nothing but circles, and then one curved surface area, that is solid cylinder. So from which a conical cavity, this conical cavity is scooped out or hollowed out. So this conical cavity also has the same height like cylinder and same diameter. Same height and same diameter. Understand? Now what we need to find is the total surface area of the remaining solid to the nearest centimeter square. What is the total surface area available for us is nothing but cylinder whose curved surface area plus one base at the bottom. One base is there, one circle area is also there. Understand? That's from cylindrical part. And from conical part, this curved surface area itself, because it is scooped out here, curved surface area is available. Outside area available is curved surface area of the cylinder plus base area circle of the cylinder plus inside also area is there because it is removed. Conical surface, curved surface area. Okay, all these three, if we find and add, we will get total surface area of the remaining solid. Got the point? Okay, what are the things given? Whose height is 2.4 centimeters and the diameter, both same diameter, 1.4 centimeter is given. Okay, understand? Now we'll write what all the things given. Height of about the cylinder. Height of cylinder is 2.4 centimeters and diameter which is nothing but DC, which is nothing but 2R is 1.4 centimeters, which is nothing but 1.4 by 2 is equals to 0.7 centimeters. Radius. From diameter we have got radius. So the data available for this cylindrical part is height and radius. Height and radius. Now you come here, cylindrical part, to find the curved surface area or total surface area. So what is required? R is there. H is there. If you come here, R and H, it is there. Okay. So to find the curved surface area or total surface area of the cylindrical part, so the data required is H and R, which is there. Okay. No need to worry. Now to find the curved surface area of the cone, what is required? R and L. R and L is required. Okay. Cone. What is given? Same height. H is equals to 2.4. Same height. Radius. Same diameter. Therefore, radius will be same, 0.7 centimeter. But one data which is not available here, that is slant height is required. Slant height. Because to find the curved surface area or the total surface area, R and L required. H is not required. Understand? R and L required. So now, before proceeding into solving this problem, we need L. And I told you that L is nothing but square root of r square plus h square. Using this data, we can find L. L is nothing but what? Square root of r square plus h square. L is equals to r square is nothing but 0.7 whole square plus h square 2.4 whole square. So L is equals to 0.7 leaves 0, it is nothing but 49, 7 times 49. 49, since 0 is there, make it 0, 2 zeros comes. After decimal 7 is there, therefore 0.49 plus 24 square is nothing but 576. Here 2.4, therefore this is 5.76. Okay, L is equals to 5.76 plus 0.49. 5.76 plus 0.49 is 6.25. 6.25. Understand? 6.25 is nothing but 625, as though it is 625. 625 is the square number. What is the square root of 625? Is 25. Therefore, L is equals to 2.5 centimeters. We have got L. So this was required to find the curved surface area of the cone, which is very much necessary to find the total surface area of the remaining solid here. Okay, so therefore we have found this. Now we have got all the data to calculate this problem. Okay, so data required for cylindrical part is H and R, which is there. Data required for conical part is R and L, but H is there. Using R and H, we have found L part. Understand? One more thing is there. So area of the bottom is nothing but circle. Circle is nothing but pi r square. R is also there. Understand? So that we can proceed into the question now. What is asked? Find the total surface area. Total surface area of what? Remaining solid. Remaining solid is equals to what? Curved surface area of cylinder, curved surface area of the cylinder plus base area of the cylinder, which is nothing but circle. Base area is available because it is solid. Okay, base area is available. Only top base is removed. So when they are carving the cone, top area is removed. Understand? But not the bottom base, which is there. Base area of cylinder plus curved surface area of the cone, which is available inside. Curved surface area of cone becomes the total surface area of the remaining solid. Understand? So we'll put the formula for this. Curved surface area of the cylinder. Curved surface area of the cylinder. 2 pi RH. 2 pi RH, whose data is available, plus base area of the cylinder. Base area of the cylinder is nothing but one circle. Circle area is pi r square plus curved surface area of the cone. Curved surface area of the cone is nothing but pi r l. Pi r l. Now only thing what we need to do is substitute everything. Okay. Now 2 into pi is nothing but 22 by 7 into r. What is r? 0.7. r 0.7. H is nothing but 2.4. 2.4 plus pi r square. Pi 22 by 7 into r square 0.7 into 0.7 plus pi r l. Pi is nothing but 22 by 7 r 0.7 l we have found here 2.5 into 2.5. You can do this individually. You can calculate so separately curved surface area of the cylinder and base area of the cylinder and curved surface area of the cone, and then you can add it. You can do in that way also. Now 7.1, that is 22 by 4 is 22 into 4, sorry, 22 into 2 is 44 into 0.1, because 0.7 by 7 is 0.1 into 2.4 plus, here also same thing, 22 into 0.1 into 0.7 plus, here also same thing, 22 into 0.1 into 2.5. 44 into 0.1 is 4.4 into 2.4 plus 2.2, 22 into 0.1, 2.2 into 0.7 plus 2.2 into 2.5. 4.4 into 2.4, 10.56 plus 2.2 into 0.7, 1.54 plus 2.2 into 2.5, 2.2 into 2.5, 5.5, okay, is equals to, after adding this, you will get 17.6 centimeter square. 17.6 centimeter square you get. The total area of the remaining solid is 17.6 centimeter square, but here it is asked to the nearest centimeter square. Nearest. This 17.6 is the nearest to 18. Nearest to, it becomes 18. Approximately 18 centimeter square. Approximately how much? 18 centimeter square. Okay. So if it would have been 17.2 or 3 or 4, then you would have said nearest means 17 centimeter square. Since it is 17.6, we can say that 18 centimeter square. So what is the area, total area of the remaining solid? 18 centimeter square. Approximately, this is approximately. So actually 17.6 centimeter square, the remaining solid. The area, total surface area of the remaining solid is 17.6 centimeter square, but approximately 18 centimeter square. Got it? Now we'll enter into the last problem of this exercise. The 9th question is, a wooden article was made by scooping out a hemisphere from each end of a solid cylinder. From each end of the solid cylinder, 2 hemisphere is been scooped out, as shown in the figure 15.11. If the height of the cylinder is 10 centimeters, height of the cylinder is 10 centimeters, and its base is of radius 3.5 centimeters. Radius of base, how many bases are there? Both the base, 2 bases are there. Okay, so 3.5 centimeter for the top one means 3.5 for the bottom of the hemisphere also. Okay, so here the thing to be found is cylinder, and inside 2 hemisphere is scooped out. Okay, so that means 2 hemispheres are there inside the cylinder. That means radius of the cylinder is equals to radius of these 2 hemispheres. Okay, now what we need to find is, find the total surface area of the article. Total surface area available is curved surface area of the cylinder and curved surface area, 2 curved surface areas of the hemisphere. Okay, now the thing given is height of the cylinder, height of the cylinder is 10 centimeters and its base radius 3.5 centimeters. To find the curved surface area, we need R and H, which is there. Okay, so now 2 hemispheres, because the base radius is 3.5, that means that 2 hemispheres are same, equal. Only one parameter required is R. that R is nothing but 3.5 centimeters. This is enough. Lot of information is there, lot of data is there, so that very easily we can find this total surface area of this particular article. Okay. Now, what is the total surface area of the article? Total surface area. Total surface area of the article is equals to curved surface area of cylinder plus 2. Since the two hemispheres are identical, so you are writing 2 into curved surface area of hemisphere. Understand? Curved surface area of the cylinder is 2 pi RH. 2 pi RH plus 2 hemispheres are there, so maintain 2 here. Curved surface area of the hemisphere is 2 pi r square. 2 pi r square. So substitute here the available data. 2 into 22 by 7 into r is 3.5 into h is 10 plus 2 into 22 is nothing but 4. 2 into 2, 4. 22 by 7, pi value 22 by 7 into r square 3.5 into 3.5. 3.5 into 3.5, which is equals to 2 times 22 is 44 by 7, 3.5 into 10 is 35 plus the same here 4 into 22 is 88 by 7 into 30, 3.5 into 3.5. 7 5 times 7 5 times 35. Okay, therefore 44 into 5, which is equals to, this is nothing but total surface area, plus 88 by 7, sorry, here you just divide it. 3.5 by 7 is nothing but 0.5. Okay, into 0.5 into 3.5. 44 into 5, 220 plus 88 into 0.5. This is nothing but 0.5 is nothing but 1 by 2. This becomes 44. 44 into 3.5. 44 into 3.5. Okay. Now which is equals to 220 plus 154, which is equals to 374 centimeter square. The total area of this article, total surface area available of this article is 374 centimeters square. Did you understand, children? Here the combination of, till now what we dealt is the combination of solids. To find the surface area of the combination of solids. To find the surface area of combination of solids, you should know this formula. So go through this properly and remember this, memorize this. Okay. Once you know that which are the solids that are combined to make these figures, know it properly and apply the particular kind of formula so that you can easily arrive at the solution. Did you understand, children? Now in the next video we are going to deal exercise 15.2. Till then, bye bye.